Welcome to the Oxygen Alliance YouTube channel, where we bring you videos on installation, maintenance, and various trainings on oxygen equipment and devices. If you have comments and or questions, drop them in the comment section below or write to us info@oxygenalliance.org. Remember to like our videos, subscribe to our channel, and hit the notification bell.
Hello everyone, welcome to our today's webinar. My name is Janet Douglas, biomedical engineer for the Oxygen Alliance, and I'm joining this call from Lilongwe, Malawi. I would like to know where you're joining us from, so please type in the chat your name and also where you're joining this call from. So today we have a very interesting topic brought by the OpenO2, where we'll be looking at the strategies in oxygen concentrators. So this is based on a case study and a true story, based on the field work, the experiences that the OpenO2 team have on the maintenance of oxygen concentrators. So I'd like everyone to be very attentive. If you have anything that you'd like to ask, please don't hesitate to take it down. When it's time for questions, I'll pose it to the audience for everyone to ask questions or give any comments based on the good work that these people are doing. So I will not want to introduce what the OpenO2 is and what they do. So I'll just hand it over to our presenters today. So for today, we have two creative, innovative biomedical engineers from the OpenO2 initiative. So we're having Kriti and Sambo as well as Aubrey Kunda, who are biomedical engineers. So reaching this far, I would like to hand it over to our first presenter, Aubrey, who will take us through the first part, and then he will hand it over to Claudia at the very end, who will then take comments as well as questions. Over to you, Aubrey.
Thank you very much, Janet. Welcome, everyone. As Janet has already introduced me, my name is Aubrey Kunda. I'm a biomedical engineer from OpenO2, which is under the Global Health Informatics Institute. And today I'm going to take you through this presentation where we're going to focus on some of the strategies in the maintenance of oxygen concentrators that we as OpenO2 have implemented to streamline our maintenance work when we're dealing with oxygen concentrators. Throughout the presentation, we're going to look at some of the activities at OpenO2. We're going to look at the challenges that we have faced in maintaining oxygen concentrators, and then we're going to focus on the strategies that we have implemented that have worked for us, and we believe maybe they can also work for the majority of those who are also working on oxygen concentrators. And then we'll focus on documentation at the very end. Much of the work that we do is field work, where we visit health facilities here in Malawi, and we assist them with maintaining oxygen concentrators. While we're also maintaining oxygen concentrators, we train the local technicians and biomedical engineers, some on-the-job training on how they can also fix these concentrators instead of just maybe dumping them or just throwing them away. Apart from that, we also collect data on the concentrators so that we can have a history of the concentrators, so that next time if you want to fix the concentrators, you know where to start from. If you, let's say, change the Zeolite last year or maybe a few months, you know that if it breaks down again, you know where to start from. Maybe you might not focus on the Zeolite, you might go to another component. So we also collect some data. So most of the work that we do is under the Sinta Malawi project, which is predominantly funded by the European Union. So some of the challenges that we have faced when we started fixing oxygen concentrators back in 2021, the first one is lack of standardization of oxygen concentrator brands and models. We have found so many brands and so many models of oxygen concentrators, and this makes it hard because, for example, if you have 100 brands, that means you need to order 100 different components for each brand or for each model, which makes it so hard to order spare parts, even Zeolite in bulk. So that's one of the main challenges. My colleague Claudia will talk about this issue when she's presenting our part of the presentation, but that's one of the big challenges that we have faced. So many brands, so many concentrators. It's hard even when you're training the engineers or technicians. You can train them on one brand today, but then tomorrow they face another brand. So some people might have problems adjusting from one brand to the other. That's one of the challenges. Another challenge is Zeolite supply chain constraints. Most of the times, what we have realized is the zeolites that we get in oxygen concentrators is not manufactured. For us, it's not manufactured in Malawi, and I'm pretty sure it's not in Africa. Usually it's found in Asia or in Europe. So for you to get the zeolite from either Asia or Europe to come to your country, to come to Malawi, it has been a challenge for us. And also considering the fact that you have different brands of oxygen concentrators, so you might need to get the zeolite from different vendors or manufacturers, which can be difficult. So it's hard for you to actually find vendors for each and every brand of concentrators. Another one is lack of locally available spare parts, which is related to the zeolite issue. Most of the spare parts cannot be found locally, so you have to order from other countries, which makes it hard to get the spares and make them readily available. And again, with the same issue of having different brands, you have to make sure that you're getting, spare parts for each and every brand or model of oxygen concentrators. Another challenge is high cost of pre-packed sieve beds. So as I said, if you have 10 different models or 10 different brands of oxygen concentrators, you might need to order 10 different types of sieve beds, right? And these sieve beds are expensive if you're ordering them one by one. For most of the facilities that we have interacted with in Malawi, we don't have the budget to cover for that. So that's why they might not fix the concentrators. They'll just leave them lying around because it's expensive for you to order pre-packed sieve beds. Also, when it comes to compressors, which is one of the main components of oxygen concentrators, it's not easy for you to get the service kits because they're not readily available. So you have to get them from either Europe or Asia, as I mentioned. Another challenge that we're faced is absence of maintenance records. So when you go to a facility, you don't know where to start from because you don't know when the last service a compressor, or if the concentrator, or if they did, what did the previous engineer do. So you have to start from scratch. So, it might take a lot of time fixing the same concentrator because you have to check maybe different components to make sure that everything else is okay before you actually fix the concentrator. You have to do a lot of troubleshooting. So that's one of the challenges that we face. First, the absence of maintenance records. And for most of the facilities here in Malawi, they don't really have a dedicated space for maintaining oxygen concentrators. Some have workshops, others don't even have workshops. So that's also a challenge because where are you going to conduct the maintenance if you do not have any space? So those are the main challenges that we have faced. I know there are some more challenges that maybe some of the people in the chat know. You can always, some of the people on the call know. You can always list them in the chat and then we can discuss at the end. But these are some of the main challenges that we have faced as OpenO2. And we have developed a few strategies to tackle these problems so that we can still do some maintenance. We understand that it's not going to be easy for you to get zeolite from other countries to get the spare parts, So while you're waiting for that, what can you do to still make sure that the concentrators are not just lying around, but you are able to, maintain oxygen concentrators? So in the next slide, I'll be talking about some of the strategies that we have applied to solve these challenges. One thing is bulk purchase of zeolite. So I'll just list them down here and then we'll talk about each point in detail in the upcoming slides. So we buy the zeolite in bulk as compared to buying a sievebed, a pair of sievebeds. We also do the refilling ourselves since we just buy the zeolite in bulk. Compressor service retrofitting. We're also going to talk about the oxygen concentrator labels and job cards that we have introduced to help us with documentation and keeping records when we do the maintenance work, and also introduction of the OpenO2 mobile workshop to deal with the challenge of limited workspace when it comes to maintaining oxygen concentrators. So as I said, it's usually hard for you to get zeolite from other countries. So we thought it's better to just buy the zeolite in bulk. So as you can see in the picture on the right, I think there are 4 25 kg drums. So that's how we buy the zeolite. We just buy those drums. And we usually buy some for lithium and others for sodium because these are the main types of zeolite that are found in oxygen concentrators. And as you can see, the lithium is relatively costly when it comes to, as compared to the sodium. And also it is more efficient. It has stronger nitrogen selectivity. And this is what most of the newer brands are using. Newer brands of oxygen concentrators are using lithium. Sodium is not mainly used right now. It was mainly used in the past. So we usually combine, we get some for lithium and some for sodium. And this really helps us because we can plan that if we get this number of drums, we know that we can be able to use it on this number of concentrators and for this period of time, rather than constantly buying the, the pre-packed sieve beds of the sieve beds one by one or something like that. It just really helps us in planning, and it makes the work easier, since we also refill the sieve beds here, which I'll be talking about in the next slide. So one of the strategies is bulk purchasing of zeolite. For those who are interested, I think you can always reach out to the Oxygen Alliance to maybe, if you would like to get the sources where we get the zeolite and stuff like that. I think you can always reach out and we can see how we can help each other on how to get the zeolite from the manufacturers to your country or to your facility if you're in Malawi as well. I think that's going to be easier. Moving on to the next one, we're going to talk about sievebed refilling. As I said, we buy the zeolite in bulk. So the next step is we have to make sure that that zeolite gets into sievebeds so that we can put it in the oxygen concentrator. So what we do is we also do the sievebed refilling here at OpenO2. So before I get into the details of sievebed refilling, just a reminder, these are some of the parts of a sievebed. And as you can see, you have an end cap, a spring, filter paper, an O-ring, disc, a round rubber, and you have the sievebed that is on the right. And for most of the sievebeds, you find the end cap, you find the spring, you find the filter paper, and you find the O-ring. The disc at the disc as well. So this round rubber is specific to Zeolite's 525 sievebeds, but the other 5 parts are common in all other sievebeds. They just differ in the shape and the size, depending on the brand and the model of the oxygen concentrator. So these are the main parts that you find once you open the sievebed itself. So when it comes to sievebeds, they're of different types. Some of them are refillable and others are non-refillable. For the refillable sievebeds, you can easily open them. They have some have like screws, some just have like a metallic clip, and others just have like a bolt and a nut that you can just use the tools available to open them. One thing that you have to take note is the spring is compressed. So once you just loosen either the screw or the nut, it's going to push the end cap out because of the tension. So you really have to be careful. You can't open them with the sievebed facing your direction, because you're going to hurt yourself or you're going to hurt those around you. So that's something that you really need to be careful about. So I will discuss how we deal with this problem to ensure that there's safety when you're opening the sievebeds. But one thing you need to note is some sievebeds are refillable in a way, because you can are easy to open, while others are totally sealed, just like the sievebeds that are shown on the. So the only way for you to open these, you might need to cut off the end cap, as compared to the others where you just remove a screw or a nut. So these are the 2 main types of sievebeds. They might come in different shapes and sizes depending on the brand and the model, but you can categorize them into the 2, that some can easily be opened. They have screws, they have nuts, while the others are totally sealed. So when it comes to opening the sievebed, you need to know what type of sievebed you're dealing with. If you have one that is a refillable sievebed, then you just loosen it up. The only thing that you really need to be careful about is the spring. I will emphasize this point. You need to be careful about that spring because it has a lot of tension. It's a very strong spring. So yeah, it can hurt you if you're not careful. But the important thing is you loosen either the screw or the nut, and then you remove the filter, just as it is shown on the image that is on the middle. And then on the far right, that's the air sievebed that has been emptied. The zeolite has been removed. If you are dealing with non-refillable sievebeds, the way we do it is we have a setup for opening the sievebeds that composes of a rotating chuck that is on the far left. You have the sievebed. On the middle, you have an angle grinder with a cutting disc. So the chunk is going to rotate the sievebed, and then the angle grinder, you just sort of push it towards the end cap of the sievebed, and then it's going as the rotating chunk is rotating the sievebed, it's going to make contact with the cutting disc, and then you can be able to cut the end of the sievebed. You really need to be careful because you want to just cut the the right dimensions, because if you also cut it on the inside, you might damage the O-ring which is there, or it's going to be hard for you to even close the sievebed. So you need to be careful when you're cutting that. So this is the setup that we have for opening and refillable sievebeds. And once you open the sievebed, you will see that the sievebed, the zeolite does not really reach the end of the sievebed. There's some clearance that they keep. As I mentioned, you usually have a filter after the sievebed, and then you have a filter with a disc, and then you have the spring on top of that. So that clearance, it also accommodates the spring, even though the spring is compressed, but there's always some space that is remaining, and you want to make sure that when you're refilling, you're also keeping that space. So when you open the sievebed, you need to take note of this clearance, right? You need to measure it or mark if you have to, but you need to take note of the zeolite so that when you're also refilling, you are maintaining the same clearance and you're not overfilling or over compressing the sievebed, which can also cause issues like overheating and many more. For the sievebeds that are non-refillable, since you cut the end cap, and once you cut, it's hard for you can't replace it with the same end cap that you've cut. So you have to find a replacement for the end caps. And what we do, we have a CNC machine that we use to cut the plastic. So usually what happens is we measure the end cap, the original end cap or the sievebed, the end of the sievebed, to get the dimensions. After that, we design the end cap using 3D design software. There are so many softwares out there that you can also use, SolidWorks, Fusion, and many more. So we do that, we design, and then we use the CNC router to cut some plastic in the shape that you have designed in the software. And these are some of the end caps that we have managed to design. This is one end cap for the DeVilbiss 525 sievebeds that are non-refillable. After you have opened the sievebeds, that's when you have to do the refilling. And when you're refilling, you need to make sure that the humidity is below 50%, because the main for zeolite to be damaged, mainly it's because of moisture. So you do not want to introduce moisture to these zeolites that you have already bought in bulk in 25 kg drums, right? So to prevent that, we have to make sure that the zeolite is below 50%. And also you need to check the type of zeolite that the concentrator is using. And this differs from brand, from model. Some might use sodium and some might use lithium. So you always need to be sure of the zeolite that you're using. You don't want to replace lithium zeolite with sodium zeolite. You might have some issues. As I already said, that lithium is a bit more efficient compared to sodium. All right, so you see that you might refill and then you're not getting the appropriate oxygen purities. And then after you know the brand, the type of zeolite, you also need to know the percentages that you're going to use when refilling the sievebeds. Some use 100% lithium, others use 100% sodium, and others also use a mixture. So the way we refill here, some of the concentrators use 100% lithium, others we mix lithium and sodium, and mainly because, as I said, lithium is more efficient, but also it is easily damaged with moisture. So to sort of like protect it, they put some put a desiccant at the bottom where the air is coming from the compressor to absorb some of that moisture before it actually does the adsorption process. Others put a layer of sodium zeolite because it does not absorb moisture at a higher rate than lithium. So when we put 20% sodium and then the lithium after that to sort of like protect that layer of lithium zeolite. After you know some of these, okay, to ensure that the humidity is below 50%, you can either use air conditioner, just put it on dry mode, and after some time, it's going to reduce the humidity. Or if you don't have an air conditioner, you can modify. We modified one portable air conditioner into a dehumidifier that we use in our mobile workshops, and then we just turn it on, and after some time the humidity reduces to below 50%. But then how do you know that the humidity has reduced, right? So you need to have some sort of sensing mechanism to know the level of humidity at that time. And how do you do that? You need to use humidity sensors. So you can choose to buy one off-the-shelf humidity sensor, as you can see on the far left in the presentation, or you can, if you like tinkering with electronics, you can build one on the far right. That's one of the humidity sensors that we have built here at the group at OpenO2. So on the middle, I'm just showing you how simple it is. If you're into these electronics, we just have a liquid crystal display, a humidity sensor, and then an Arduino, and you can be able to develop your own humidity sensor. So one thing that I can emphasize here is to make sure that you're using industry-grade humidity sensors, because most of these common humidity sensors might not be as precise, so you get the wrong readings. But then you need to make sure that you're using a sensor that is precise, and it will give you the right readings. Moving on, so as I said, you need to be careful when you're opening sievebeds because of the spring. So what we did here at OpenO2, we have a device that we call the sievebed refilling jig that helps us to safely open and close sievebeds. It controls the release of spring tension from the sievebeds. So as you can see in the image, that's the first prototype of the sievebed refilling jig. You have the sievebed on the middle that is shown by the arrow, and then you sort of have like the wooden bar that is at the top. And then when you push that bar down, you press on the sievebed. And this prototype was mainly developed for a specific type of sievebed. And the main problem with this prototype was it could only accommodate a specific type of sievebed. So if you have, as I said, we find different brands or different models of oxygen concentrators. So if you have 10 different brands, with this one, you can only open one type of sievebed. If you have 10, you might need to develop 10 different refilling jigs if we were still using this design. So this design was the first prototype. It worked for just a specific type of sievebed. And another problem we had with this prototype is that it needed a number of people for you to do the refilling or the opening of sievebeds, because one person had to be holding the bar to push on the spring to release some of the tension on the spring, and the other person had to be removing the metal clip on the sievebed. So you needed 2 or 3 people to do the opening of the sievebed. But then we made some improvements, and this was the second version, the second prototype of the sievebed refilling jig. Same functionality, but now with this one person can open a sievebed, do the refilling, and be able to close it. The main advantage with this one is you can refill different sizes or different types of sievebeds, because it just uses sort of like spacers. So if you have a smaller sievebed, you use maybe bigger spacers to just tighten the sievebed. And if you have bigger sievebeds, you just change those different parts to accommodate that sievebed. So with this prototype, we can open and close, I think, about 4 or 5 different types of sievebeds. So which is good, because one device, you're opening and closing about 5 types of sievebeds instead of having different types of devices. So this is what we use currently to open the sievebeds for refilling and close them. So for the non-refillable sievebeds, since we cut them after we have designed the end cap, one way of fastening those end caps is we just drill a hole and we use 3 screws. So in the image, you can only see 1 screw, but there are other screws on the other side, and we tighten the screws to make sure that the plastic end cap is secure and it is safe. But how sure are you that it is secure after you close it? How do you know that there are leakages? So we don't just end it here. We do a pressure test to make sure that there are no leakages after we have done the seedbed refilling. We have a setup of a compressor, some water separators, a bore valve, and a pressure gauge to do the pressure testing. So as you can see in the image, you have the compressor as labeled, and then we have 2 water separators in series. This is just to make sure that we're not introducing any moisture into the seedbed, since now we have refilled the seedbed and we do not want to damage that zeolite inside the seedbed. Yes, it's an oil-free compressor, just like the ones that are in oxygen concentrators. So what we do is we connect the compressor to the water separators, to the bore valve as well, to the seedbed, which has the pressure gauge at the end. And then once you turn on the compressor and you also open the bore valve, you'll be checking the pressure gauge. Once it gets to 40 psi, you close the bore valve to maintain that pressure that is in the seedbed. So if there are any leakages, you can be able to notice them using, we also use some foam, some soapy water, and we take the foam and apply it on the ends of the seedbed. So if there are any leakages, you can see bubbles that will show you that there are leakages on this seedbed. If there are no leakages, then you slowly remove the seedbed. You need to be careful, again, because now you're dealing with pressure. 40 psi can still be dangerous. So you need to slowly bleed off that air until all the air is gone out of the seedbed, and then you can seal it. So after it passes the test, we pre-pack it and we put it in the, we pack it, we seal it, and we put it in the OpenO2 mobile workshop, which my colleague is going to talk about in the upcoming slide. So we use 40 psi because most of the seedbeds, the pressure in the seedbeds is about 20 to 30 psi around there, depending on the brand. So we thought that 40 psi is, we added 10 psi as a safety factor, and that works properly. After we have done the seedbed refilling, one other challenge that we have faced, or that we have seen in most of the facilities, is the unavailability of oxygen analyzers, and this was highlighted mainly during COVID time in 2021, when we had just started fixing oxygen concentrators. So we thought that one way of also dealing with this challenge is to make our own handheld oxygen analyzer. So we have one, as you can see on the far left, that's OpenO2 oxygen analyzer. It's made at OpenO2, and we also have off-the-shelf oxygen analyzers to do some quality checks. So I'm just going to talk about the handheld oxygen analyzer that we developed. This is where it all started. We're using an Arduino for prototyping, and this is just the connections, Arduino and the oxygen sensor. It's using an ultrasonic oxygen sensor. After we did the circuit diagrams, we designed the board using circuit designing software, and we also have a CNC engraving machine that helps us to make cover boards where you can plug in the different electrical components like the Arduino, the ultrasonic sensors. And then after we did this, on the far right, that was the first prototype, and it worked. As you can see from OpenO2, it's showing the oxygen purity and the flow. This was the first prototype. After some improvements, we designed it, and this was the final prototype, I would say, at the moment. It's still undergoing improvements, but this is where we are at the moment. And this is what it looks like after we design an enclosure for it. So this was really, it really helped us, and it also helped most of the facilities, because during COVID, it was hard for you to get away of just checking the oxygen purity on different oxygen concentrators. So that's it for my part. I'll hand it over to my colleague Claudia to take you through the rest of the presentation. Thank you very much.
Thank you very much, Aubrey. But before Claudia comes in, the OpenO2 in collaboration with the Oxygen Alliance, created a video on the refilling of the Sievebeds. So we have posted a link in the chat. You can watch the video on how you can do this. This video is also available on the app, the BME Conta app by the Oxygen Alliance. So you can also go there and check it out. Over to you, Claudia.
All right, thank you very much, Janet. So as one of the challenges that my colleague mentioned earlier is diversity or lack of standardization of the oxygen concentrator modules. So since 2021, the OpenO2 mobile workshop, after visiting different facilities, we've met about 91 different models of oxygen concentrators. And these models, when we narrow it down, there are about 43 brands in Malawi. So this is from the sites that were visited since 2021. So as I said, this is a challenge because it is difficult to order spare parts and to service some of the concentrators. So one of the major issues when it comes to oxygen concentrators is when it comes to servicing the compressor. So different compressors or different concentrators have different compressor models, right? So I'll just give you a scenario. So imagine you have okay, as I said, 91 different brands, right? Or 43 models. So that simply means you need to order, or you need to have that amount of service kits for the compressor. So as OpenO2, we saw that this is not a realistic thing to do, or it's difficult for one to achieve. So we practice something that we call compressor service kit retrofit. So for this, what we did, okay, before I go into the whole what compressor service kit retrofit is, I will go through the parts of what the compressor service kits are, so that we are together when I'm explaining the exact things that we do. So for us to understand more on the service or the service kits, that means there's a link on the slide, but also I think the host will be able to post it in the chat so that you can access the link on the compressor overhaul. Next slide, please. So the main components of the service kit are the cylinder sleeves, the O-ring, the reed or flabber valves, the cylinder sleeves, and the head gaskets. So over time, these things wear out and they affect the whole performance of the compressor, which affects the overall performance of your concentrator, and they need to be serviced. So as I mentioned, due to the diversity of the oxygen concentrator models, it is difficult for a facility, or even for us, OpenO2, it was difficult to order or to have all the replacements for the particular models of the compressors themselves. So what we did is what we're calling the compressor service kit retrofitting. So for this, we had to collect data on the dimensions of the cylinder caps, the sleeves, mainly the cylinder caps, the sleeves, and the reed valves. So what we did after we collected the dimensions, we noticed that for some of the compressors, you can use cylinder sleeves from one compressor on another. So that means you don't need to have all the compressor service kits for that particular model, because you can use one from another compressor. Next slide, please. Yes, so in this slide, we have a worn out cylinder sleeve and a new cylinder sleeve. So for the worn out cylinder sleeve, so this it collects, due to friction, it creates that black line, right? Or it collects black substances due to the friction during the compression. So what we do is either, depending on the damage of the sleeve, it's either we replace the whole sleeve with a new sleeve, or we use a soft sandpaper to just wipe, to clean the black substances, and then we invert it when we are replacing it. So if you just clean it and invert it, that means you don't need to actually put a new cylinder sleeve. All you need to do is, that means you're still using the old one, right? So for this, that means your problem when it comes to the cylinder sleeve has been solved. Next slide, please. So another thing that usually wears out is the cylinder cap. So in this picture, we have a worn out cylinder cap and the new cylinder caps. So for the cylinder caps, usually it's in the sides that are usually eaten up. So when they're eaten up, it affects the whole performance of the compressor itself. So for this one, usually once it's fit in a compressor, that means you need to, when you're servicing, you need to put a new one. So this is where usually the dimensions come in, because you can, as long as they have the same diameter, the cylinder caps, right? That means you can use it on another compressor. So all you need to know is which ones share the diameters or which ones share different particular dimensions so that you're able to fix them. So for this, you can actually just measure depending on the ones that you have at your facility. Next slide, please. So another problem that we face when it comes to when we're servicing compressors is that we find broken reed valves. So when it comes to replacing the reed valves, first of all, you have to make sure that the hole on the reed valve, if you are using one from a different compressor model, that means what you have to make sure is the hole that's on the reed valve is the same size or the screw size that's in the one you're actually replacing, and also the dimensions of the reed valve fit perfectly on the hole that's found in the that lets air in or out of the compressor. So I think more of this can be seen on the link that has been pasted on the compressor overhaul video that's on the Oxygen Alliance YouTube channel. Next slide, please. So as one of the challenges that was mentioned was lack of spare parts. So as OpenO2, we practice something that we call scavenging for spare parts. So scavenging of spare parts simply means that you are taking usable components from a particular oxygen concentrator, right, and placing them. Okay, so this concentrator that you're taking from, it's either old or it has some particular functions that are not working. So you take this particular usable component and place it, and you can replace it into a concentrator that needs that particular usable component. So for example, if you are at a particular facility, that means if you see that there's a particular, if you have an old concentrator, that means you can take particular parts of that oxygen concentrator that can still be used, right? So for example, in the picture that we have on this slide, these are just two boards from an oxygen concentrator. So just an example. So if one of these, the oxygen sensor is not working or it's broken, right? And you have an old oxygen concentrator that's just there that you can't unfixable one, but then it has a functional oxygen sensor. That means you can just take that functional oxygen sensor or functional board and replace it in the one that you're fixing. So for this scenario, so ideally where I'm heading at is, let's say you have 2 oxygen, or let's say 10 oxygen concentrators that are not working, right? But then what you know is you can actually take a part from another oxygen concentrator and replace it in another oxygen concentrator. So if you do this, that means instead of having 10 oxygen concentrators that are not functional, after you do the scavenging of spare parts, now you can at least have maybe 5, 6 oxygen concentrators. So that's better than none, or it's better than just having all the concentrators broken down when you can scavenge for parts. So this usually works for compressors, for concentrators that are of the same brand or model. Next slide, please. So we also talked about the problem of limited workspace or maintenance workspace. So as OpenO2, something we take pride in is the mobile workshop. So these are buses that we converted into workshops. So we removed the chairs and installed different drawers that we put all the spare parts that we need, all the tools that we need, so that when we're going to a particular facility, we have all the tools that we need. So in the picture, in the left picture, we just have part of our team doing a checklist. So before we go to a particular facility, we do a checklist, making sure that we have all the tools that we need. And also, as my colleague mentioned earlier, we also do the refilling of the Sievebed as part of the checklist. So as we're going to the field, we refill these Sievebeds. So this is just part of the checklist that we do before we go to a particular site. So we also have sockets in this, we installed sockets in this mobile workshop. We also have a genset with us that we carry with us, because in most of the facilities we meet, we find issues of low voltage or no electricity at all. So when it comes to an issue of low voltage, it's also difficult to maintain an oxygen concentrator, because when we're testing the oxygen concentrator after maintenance, it's usually low voltage can also affect the performance of the oxygen concentrator. So we use this genset that we carry with us in the mobile workshop to also solve those issues of low voltage. And we also have a tent. So this tent, just we use it to just increase space. So usually all our team might not fit in the bus when we're maintaining the oxygen concentrators. So we have a tent for shade, so that part of the team, we have tents and tables, that workstations rather, that we carry with us in the bus, so we create our stations in those particular facilities that we visited. So then that's where we do our maintenance. So this workshop, this space that we create is closer to our mobile workshop, so that it's easy for us to carry the components or the tools with us. So one of the challenges that we talked about was lack of documentation, right? So lack of documentation has a lot of effects. So some of them is that it's difficult to track the maintenance history of the particular oxygen concentrators that are worked with. So as OpenO2, we created different labels. So these labels help us track or make informed decisions when we're maintaining oxygen concentrators. So the first label that we have is the concentrator registration label. So all the concentrators that OpenO2 assesses has this ID, has a particular ID. So when we assess, we give that oxygen concentrator an OpenO2 ID, which is used from our end to track the oxygen concentrators that we're maintaining. So when we maintain it, we write the purity that was found after a particular maintenance and the date itself. And so that for that we use the oxygen purity labels. So this helps us to track the purity, or to make informed decisions for the when it comes to maintaining the oxygen concentrators. So this is because usually, let's say if I go to the field today, right, or if I receive a call that this oxygen concentrator is not functioning, so what I will do, I will look at the purity of its last service. So assuming it was 95.6, right? So that means I'll know, okay, how many hours has it been since its last service and at what purity it was. So depending on that information, I'll be able to make an informed decision depending on the last purity that was there and the hours that he has run. And also, we have the compressor service model. So when we service compressors, what we do, we put the sticker of the service compressor. So for this one, we tick whether we've replaced the caps, the sleeves, the head gasket, the O-ring, or the reed valves, and on what date. So similar to the purity ones, the function is almost the same. So this one helps us to track okay, so depending on how many hours or the last time it was serviced, you are also able to make informed decisions on whether you, so okay, so for this, I'll just give a scenario again. So for example, your concentrator is giving you low purity, right? So this is a few hours of running after you've serviced your compressor. So now you know that, okay, so I serviced my compressor on this particular day. Do I need to go back and service this compressor that was serviced a few hours ago? So as I said, so this just makes you make informed decision depending on the last service, because also the compressors have certain amount of hours that they have to run before like they need a natural service. So the amount of hours can also depend whether you need to service your compressor or not. And the other one that we have is Zeolite refill label. So as Aubrey mentioned, he talked a lot on Zeolite refilling. So so on Zeolite refilling, what we do is after all the information or after all the activities that we have done or Aubrey mentioned, we put this sticker and the ratios that he also mentioned and on what date. So one thing that we also have is a job card. So this job card is basically tailored to the information as OpenO2 or the information that we want to collect as OpenO2. So this is just like a cover page for documentation purposes or for tracking purposes, which biomedical engineer from OpenO2 was there when this facility was visited and on and which facility and the one that supervises that particular facility. Next slide, please. So this is just a sample of what our job card looks like. So as I said, this is the information. So this job card is tailored to OpenO2, the information that we want to be collecting, right? So as we said that we have the oxygen concentrator IDs. So for each ID, so for each concentrator that we assess, we write the ID, we write the model, we write the status, whether it was functional or dysfunctional, and we also measure the purity. So if it was dysfunctional and it was collected for maintenance, what we do is we record the problem. After we record the problem, the work that we have done and the consumables that we've used. So all this data that we collect helps us to, first of all, track the performance of a particular concentrator and also track the consumables that we're using or the consumables that we usually use so that it helps us when we're budgeting or when we're planning on buying these consumables that we use when it comes to maintenance of oxygen concentrators. Next slide, please. So finally, the tool that we use to collect this data is Open Data Kit. So we made different forms. So we have a form for registering the oxygen concentrators. We have a form that also registers the final purity and the initial purity. So the form that I showed you prior to this one, so that one, so all the data is collected after you fill the final purity form. And we also have compressor registration. So compressor registration is what helped us to know which models are there when it comes to the compressor brands that are on the market or the ones that we have made as OpenO2. So this marks the end of the presentation that we have. We hope that you learned a thing or two on what the strategies that OpenO2 uses to overcome some of the challenges that we have faced when maintaining oxygen concentrators. And I hope you adapt some of these solutions. Thank you very much. Over to you, Janet.
Thank you very much, team, for that wonderful presentation. I know we have a lot of comments and questions that were pasted in the chat. I'll just take about 3, and then if there's a hand from anyone who'd also like to ask a question, please, I'll give you a chance to do so. I'll just take one hand, but because we have a lot of comments here, so I'll just go straight to the comments. So the first one is coming from firstly, he said this is a great innovation for the OpenO2 analyzer, but then the question is it rolled out for production or sale? That's the analyzer. Is it rolled out for production or sale? And the other question was from the same person saying, how does one apply for the OpenO2 training cohorts? So I think you can take these questions first, and then we'll go to the other questions for the engineers.
All right, Chimome, I think you're not take the questions.
Yes, sure. Thank you so much, Aubrey. So my name is Chimomatius, and I'm the program manager for the OpenO2. Firstly, I want just to repeat that the OpenO2 is a program under the Global Health Informatics Institute, which is largely, I say entirely, a non-profit organization. So we created these oxygen analyzers as a response to the COVID-19 pandemic and also to help us during field work. Currently, there are no plans to continue with this. Of course, we've made some modifications to have one that actually does also measure pressure. But for now, we don't have this in production other than the ones that we rolled out during the COVID-19 pandemic. For the other question, I think for the very first question as well, as I said, we are a non-government organization and we do not sell. The second question is, how do you apply for this? As of right now, we are mainly taking recent graduates or those pending graduation from Malawian universities, mostly two universities, Malawi University of Science and Technology and the MUPAS, Malawi University of Business and Applied Sciences. So this is mainly how we do it. But if you're interested in the cohorts, assuming you're not from Malawi, you can always reach out to us through the Auction Alliance, of course, and we are going to take it from there. I think this pretty much answers the questions that you asked. Over to you, Janet, unless there is something else.
Thank you very much, Chimoe. So I'll just go straight to another question. I hope Engineer Goti, that was clearly said. I know there's a hand from Aubrey, but can you please come after I read this question? This is a question coming from Emmanuel Chawea. So just out of curiosity, are these innovations open source or they are patented? I see a lot of good innovations that could help the low and middle income countries in general. Kudos team. So the question is, are these innovations open source or they are patented? So I think you can take that question, but we'll start with Aubrey. You have raised the hand, so then you can go ahead answering the question. Thank you.
All right, thank you, Janet. So I just wanted Chimome to also clarify on the open source part. I think he'll clarify. I think when he's clarifying, he also probably answer the question as well.
All right. Again, thank you, Janet. Much of the products or innovations that we've created and are out there are open source that people can replicate at any time. The auction analyzer is the example. The source code is on GitHub, and also the other files, like the one used for the computer-aided design, it's actually there and anyone can replicate. For the Zeolite Regeneration, the paper was out as a preprint. Anyone can replicate. So pretty much everything that's out there, which is shared, people can replicate. Of course, we are also working. There are other products that have not been mentioned here that we're working on, and these they are not designated as open source per se, which partly is the reason that they have not been shared. So I would say there are some that we're not sharing, and we're in the process of getting to a place where we want to patent, or we are going to patent them, and they are not out there. And there are other products that we've put there as open source. So I hope that answers your question.
Thank you very much. So there is a question about sharing the presentation. I think this is an interesting thing to say. The BME Conza app has been going through a series of improvements. So right now, if you go to the app, you'll find videos about the webinars that we've been having, the maintenance videos that we've been talking about, as well as the PowerPoint presentations. So you will get a copy of this recording through our YouTube channel. We do record and then we paste on the YouTube channel for the Auction Alliance. At the same time, if you go to the BME Conza app, you also have access to this presentation as well as this recording. So moving forward, there's also another question from, I'll just read the question from Teshaga, and then I'll also read another one from Emmanuel Chawe as well. So Teshaga is asking, how long does it take to repair a compressor? How long does it take to repair a compressor? And another comment or question from Emmanuel Chawe, he's saying, tapping from your experience, I think some of these problems are at policy level. For example, do you think it could be possible or it could be important for Malawi or SADC to choose one model of oxygen concentrator, which would mean less confusion in spare parts stocking and spare parts scavenging from obsolete ones? I'll read that again. Tapping from your experience, do you think some of these problems are at policy level? For example, do you think it would be important for Malawi or SADC to choose one model of oxygen concentrator, which would mean less confusion in spare parts stocking and spare parts scavenging from obsolete ones? I think you can take those questions and then we'll close the call. But then before that, I would give somebody a chance to ask through your hand. Yes, over to you, Claudia. Address the questions.
Okay, so for the first one, how long it takes to service a compressor? So I would say roughly 15 minutes, but then it highly depends on how often you've done it and your experience. So it might take less or longer than the 15 minutes, but then at the end of the day, it's about your experience when it comes to maintaining the compressors themselves. And second question, ideally, I would say that it's really at a policy level when it comes to trying to standardize the oxygen concentrator models and brands, right? I think I've heard that they're trying to standardize this. I don't know at what level this policy is at, but then I think it's a good initiative and it would make it easier to do the scavenging or to stock the spare parts themselves. And I think Jimumi has a comment on this as well. Thank you very much. Over to you, Jimumi.
All right, thank you, Claudia. I just want to put as an addition to what Claudia has said. So the project which OpenO2 is working on going around the hospitals to maintain and fix oxygen concentrators, supported by the European Union, the main focus is to, at the end of the day, to come up with data to show, to influence policy change based on the experience that we've gathered from the field. Like, we are giving them all these problems. At the end of the day, we have a meeting with them, we share the data. At least we want to use this to influence the policy, to change, to move towards standardization, which, as Claudia said, it's something that's ongoing, and soon, with our plan to have the advocacy event and dissemination event to share the what we found in the field, we strongly believe that this is going to help us. Also, the efforts that Oxygen Alliance is putting, working with the ministry and everyone else who is involved in procurement for medical equipment to move towards standardization. So largely, I would say this, what Oxygen Alliance is working on and what the OpenO2 is working on, is going to go a long way to influence policy change. And of course, I can't speak at the SADC level, but for Malawi, that's the case. Thank you.
Thank you very much, Mumi. I know we have gone past the time and I would want us to close, but then before that, I think there's a very interesting question. After this, I'll close. They're asking how many facilities have we assessed and supported as OpenO2? I think you can just take this one and then I'll close the call. Thank you.
So I think I can take that one. So we have supported different facilities at different levels. So we have mission hospitals, we have district hospitals, even referral hospitals here in Malawi, which are also tertiary hospitals, or the central hospitals. They've added up to around over 90 facilities. I don't have the actual figure, but it's above 90. So all that data that was being shown was from these 90-something facilities across Malawi and on different levels. So they're not only district hospitals, they're district hospitals, central hospitals, and even mission hospitals, even some health centers. So different levels, different types of hospitals, over 90 facilities. Thank you.
All right. Thank you very much. Would like to thank everyone for joining this call. I know Wardenson and Dawid, you said something to do with zeolites, and I understand I saw a comment. I believe the OpenO2 team also saw that comment that currently a team in Ethiopia is trying to do an assessment, I think, in the production of zeolite, and that would help in solving the bottom line. I think for more details, I'll just ask the audience or everyone who is here, you can just reach out to the OpenO2 website where you can also get some of this information. But then if you have any other question, reach out to the Oxygen Alliance at info@oxygenalliance.org. So you can reach out to us if you have any questions, quality, or you can also go direct to the OpenO2 website for any clarifications there. I think there's some contact details there. You can reach out to them directly. But if need be, please reach out to us. Just a reminder, check the BMA Conza app. There are a lot of improvements that have been made. Please don't forget to use it as biomedical engineers. Reaching this far, I'd like to thank everyone who has joined the call. I believe this was very helpful to everyone. Chimwemwe, you have raised the hand as I was closing. Can you just please unmute and speak?
Apologies, Janet. I've seen that there's a question from Mishik Swamba. This is good. Do you have plans for extending this to other countries? Because if you did, it could be very helpful and good. I think we can have a separate call with them or communicate after the call using the Oxygen Alliance database, maybe to talk about the Oxygen Alliance and where we are, what we're doing. And if you want to learn more about the OpenO2 and how you can do it in your country, of course, we are available to talk about that. I think this extends to anyone.
All right.
Okay.
Thank you very much. Wishing everyone a very good evening. I don't know other countries in the morning, but thank you very much for joining our call. Bye from here.